Hello, everybody. Thank you for taking the time to join us for this webinar. Firstly, some housekeeping. You're all placed on mute, but please add questions to the private chat window, and we will endeavour to answer those at the end of the presentation. There will also be a short survey near the end of the presentation. It will take a few seconds to complete, but please do complete that. So I'm Chris Litchfield. I recently joined Mayor's sales team, but have been involved with the products within the Siemens portfolio for more than 20 years. Presenting today is Adam, with 25 years experience in simulation and has been with Mayor for over 6 years. If you see from his slide, I'm sure his dustbin lid is still in use today and hasn't been superseded, so don't worry about that, Adam. Also joining us is Stuart. He's part of the Mayor team for over 3 years. Prior to Mayor, he was 20 years involved in aero gas turbine industry. So being based in Derby, no prizes for guessing who Stuart was working for previously. Now I'm going to do a quick introduction of Mayor. As I mentioned, I'm fairly new to the Mayor team, but have been aware of Mayor and their solid reputation for many years. Since joining, I've been surprised at the presence they have on client projects. We are an engineering company that also develops and sells software. We currently have 4 offices, head offices in Montreal, Canada. We have quite a large presence in the USA, and in more recent years have moved into UK and France. With over 30 years of experience and partnering with Siemens, specialising in simulation, but also across the design portfolio. We have a growing dedicated IA team, and we'll cover that topic in future webinars. All the different engineering product teams are also involved with client projects, so they are not just developing and supporting software tools, they are using them on real world projects. They're moving from client to client, industry to industry, naturally creating best in class practices. And that opens up those lessons learned to new clients. I'm now going to pass over to Adam, and he's going to start the presentation and demonstration.
Thanks, Chris. So just sharing with you today's agenda. It's pretty simple. I'm just going to briefly touch on kind of automation, some of the benefits, and then we're going to run through some real examples which we've worked on with clients. And my colleague Stuart's going to take you through the first one in a minute with CTIM. Just to reiterate Chris's statement, please feel free to ask any questions as we go along in the chat, and we'll try and pick them up at the end. So I'm going to jump in now with a little bit about the automation benefits and some of our kind of experience in this space. So quite a lot on this slide to take in, but on the we'll start with the discovery section. So we're just looking really at the process of capturing and automating simulation processes, and then potentially some of the benefits and what that enables. So if we start with looking at sort of discovery, in our experience, we've found that often simply documenting what you're doing in your simulation processes, although it sounds simple, will reveal quick wins quite quickly, and just give you something to get going with. We've worked with clients just to capture their workflows, and then we can often leverage out of the box capabilities, like advanced capabilities, to bring some benefits very quickly. Then we would start typically moving into what we call digitalization, essentially capturing these processes. And there's often some real quick wins we can get with a little bit of investment, looking for kind of repetitive tasks, changing in data formats, error-prone, human error-prone processes where you're entering data, those kind of things. Automated results processing is often a win, generating a nice set of results automatically, CAD cleanup. And there's a diverse set of tools that we're using, and I guess most of you will be familiar with a lot of this, but advanced CAE and CAD configurations, scripting comes into this. There is a place for tools like Python and so on. And then tools like HEADS, which is a workflow automation engine. And we're going to have a look at all of these in this session and explain a little bit more. So we can use these tools to kind of quickly capture our knowledge, start making testable, manageable processes, and we start realizing benefits, faster simulation turnarounds, higher quality, less mistakes in there, ability to share results consistently within the organization. But what's really cool about the kind of automation and where we see some of the higher value benefits is you're unlocking new capabilities. So a lot of this is the foundation to doing more advanced optimization and design studies in kind of classic simulation, but also then taking that and using it to build reduced order models in kind of machine learning and so on. So you can build predictive models of your system, and even take this to the point where you can integrate into like MBSE type model systems where you can automatically validate requirements, for example. So doing this groundwork really opens up a lot of options for future benefits. So just to sort of give you some inspiration, and that's one of the ideas of this session, is just to give you some ideas of the art of the possible. I've listed a few, and this is not exhaustive of the types of automation processes that we've worked with different clients on and can support and work through. And we're gonna look at 3 today, as I said in the agenda, and these are all areas we've looked at. So the first one that I'm going to look at, I'm going to hand the ball to my colleague Stuart, and is a kind of NX open-based project in SimCenter to look at different design variants. So this is kind of looking at different, the kind of the first one on this list. So Stuart, I'm going to hand the ball to you.
Cheers, Adam. Yeah, so as Adam mentioned, this is what I'm going to show you in a few seconds is an example of a project that we've done with a company called CTIM, based in France. So we worked with them to develop a set of apps using NX Open, integrated with Excel and Python to streamline their SimCenter 3D analysis processes, and also enable some robust design and optimization. So if you could play the video, Adam, that'd be great.
Okay, so this is a demo on how we can use NX Open to streamline some simulation processes. So this was a piece of work that we did for a company called CTIM, based in France, and they predominantly want to looking at bolt stressing, and they want to automate some design studies to be able to get more insights into the simulation and do some optimization and that sort of stuff. So we worked with them to create a suite of apps to help them with that. So they have this model set up, and it's got some selection recipes for the areas of the model that they're interested in, and they've created some expressions. These expressions are linked to the geometry, so as these change, the geometry will change and everything will update. And they've also got some analysis parameters in there, like force and pressure. So the first step in this is to export the variables to a template. So they've got a template in Excel, and it's blank at the moment, and this first app will just export the expressions that they want to do a study on. So we click on this. These are all custom GUIs that we've created for them using NX Open, and the GUI pops up, and we've got to choose the template file name, which is already in there. The folder where that file is the right one. The name of the study. And then we're going to say we want to open the Excel file after we create the template, and it should show us what we've got in there. Hit OK. And as you can see, it's exported the expressions that we're interested in, and we can start creating a study. Okay, so I'm going to do a study on the flange diameter and the flange thickness. I'm going to put some values in here. Let's put 11, and let's put 10, and here we'll put 14, 13. So if we save that now, this is going to be used to run a design study. The blank fields here, they'll just use the same as they were previously, so same as the nominal model. We'll save that and shut it down. Okay, so we close down these GUIs. So the next thing is to run the design study. We open up this. Now I mentioned we've got some selection recipes already created. These appear in here, so the NX Open script will go away and look for these selection recipes, any selection recipes in the model, and we can say, right, these are for displacement, so we want to select displacements for that, and we want to select stresses for that. We have to update the template file with the output selections, and then we've got some options, so whether we want to transform the results into a different CSYS, and we can keep the results files because we might want to load these up and see what the results look like. So next thing to do is just hit run study. So what this will do now is go away and update the model, and it will run a simulation. You can see the progress down here, and it's writing and solving, and then it's going to run the Nastran solver. Now this is going to take a few minutes, so I will skip this step and we'll get to the point where it's run the study. Okay, so that study's finished now. All the runs have passed, so we can hit OK and close this window down. And what that has done is created a folder. New study. It's got the 2 runs in there, so it's got a log file as well that shows you both runs have passed. If it failed, it gives you some more information in there that says why it failed. And then we've got the 2 run folders. So we've got the OP2 file, the analysis files for that, and then we've got some results as well. If we open this up, you just have to format this so it looks nice. And we've got the displacement results for each of the sub cases. So we've got preload here, all the displacements of the different nodes that are within the selection recipe. And we've got the nonlinear steps as well for all the different nodes in the selection recipe. And a bit further down, we all have the stresses. So yeah, we've got the preload cases and all the different stress results. So you can see how this can be useful to do some optimization on these studies. You can join the results files together because we have the same results file for 2, and then you can start doing some optimization on that outside of the NX environment if you want to. Cool. So let's go back to the window. Okay, so we've come back into the NX window, the results window now, and the CTIM wanted a few extra apps to export some data just from a normal model. So if we have a look at this, we've got some nodes here, and we might want some results from that. So let's say node 1, 2, and 3, we want the stresses for that. And we can use this export curve data tool, and we've got the option to select the different solutions if we've got more than one solution, and where we want to start and stop the iteration. So let's do it for all. So this will automatically select all of the load cases. So we've got sorry, it won't. So we go to the we want the non-linear, and we want the last increment as the last one that we want to export. And we can say, all right, let's look at the stresses. Which component of the stresses do we want? Let's say mean, and then we're going to put some node labels in here. So let's say 1, 3, 2, and 3. Okay, and then we are going to select a file name, so we'll call it results. We're going to put it in our folder, and then we're going to export the data. So let's have a look at what that looks like. Results file here. And as we said, we've got the stress at node 1 for all of the different load cases, sorry, all of the different iterations, preload through to the non-linear loads, and same for node 2 and same for node 3. So it gives them a bit more flexibility to be able to export results, and they might want to import this into some optimization software. Let's shut these down. And the last thing that we've created for these guys is a image exporter. So for reporting, they might want to show an image of a high stress region, so they could zoom into here like that, and they want to show a picture of how that stress changes through all of the different iterations. So we can use the export frames app to export them images, and we go into this result images. We've got the timestamped images and load that up, and you can dump that into a report if you want to. So this is the NX Open project. It's a Python project and it's in Visual Studio Code. And as you can see here, we've got some functions that we've coded up to do certain things. So this one's reading expressions from an Excel file. We've got some NX Open ones here, so exporting study expressions. This is all object oriented, and crucially, this is all tested. So it's tested with a test project that we've created. So each function has a test case for it. And then you can see here where we've run some of these and they've all passed. Now, this is crucial. So if the end user wants to add a new geometry, or maybe you want to upgrade to the new version of NX, because we've got all this tested, we can really quickly add the new geometry or new version of NX, or add some new functions, have a test case for it, and make sure them tests pass, and then package the software up and the applications up and deploy it to the end user pretty seamlessly. So that's the end of the demo for this. I'm now going to go back to the slide pack.
Yeah, okay, so that video showed how we use NX Open to automate simulation processes within SimCenter 3D. And we've listed a few benefits on this slide, but the key one for me is the engineering time that's saved by the automation. This frees up engineers to spend time on the tasks that really add value to the project. And also this automation, it lowers the bar to entry, so less experienced engineers or junior engineers can work on tasks that would have normally required an expert user before. And then also, as we mentioned before, this enables robust design optimization, which can be used to design better products, essentially. So that's it for the NX Open demo. I'm going to hand back over to Adam now to talk a bit more about batch meshing.
Thank you, Stuart. So moving on to kind of another automation example that we've lined up for you. Again, work we've done with many of our clients. So here I'm going to take you through a little bit of some of the capabilities where you want to speed up the meshing process. So expect some of you are SimCenter 3D users, so you'll recognize some of this. And the kind of objective here is to kind of reuse mesh rules, or meshing rules, if you like, to mesh new parts that we give the SimCenter tools. So I'm not going to really cover in this demo the defeaturing and cleanup. That's something, again, we've automated for clients, and there's a lot of great tools inside SimCenter to do that. But it would be similar to what you've just seen in terms of you can extend the functionality as well there. Another thing to say is all this is associative. So from the original CAD part through the defeatured part to the assembly of FEMs, it's all associative. So any change can be then cascaded down through those items. We're just going to focus in for today's session just on what you can do pretty much out of the box with some templates and selection recipes to automate a meshing process of parts. So let's just jump in, and we've got another demo for you to share.
Having gone to the effort of creating good quality mesh to the correct specification, we would want to be able to reuse that work as much as possible. However, often this is difficult because when we create mesh, we are manually picking surfaces and faces. So how can we automate this process and create templates that will help us? Well, if we have a look at this example here and go to the CAD assembly where this is constructed from, let's have a look at one of the parts in that CAD assembly. If I interrogate the faces on this part and look at their properties, we can see that a 12mm shell property has been allocated to these surfaces. Here we can highlight which faces have had these properties allocated. So on this component, these are the surfaces to be meshed, and this is the specification to be used. These tags sit on the CAD part, and they will remain there through updates of the part. Returning to the finite element model definition, we can reuse those tags then to create selection recipes to find the surfaces by a particular tag. So if I show the contents of this selection recipe here, you can see the faces appropriate for the 12mm mesh allocation. Then when we come to create a mesh definition, we allocate it by selecting a selection recipe. And we set up the correct specification for that particular allocation. So here you can see I've got selection recipes for 10mm, for the spreaders, 12mm on the ribs, (20mm) on the leading trailing edge reinforcements, and 50mm on the top and bottom face of the airfoil here. By using this approach, we can now turn this FE model into a template and apply it to a completely different set of surfaces. So now, if we open up a completely different assembly, with radically different geometry, we can reuse our element model as a template. Let me just open up one of these parts, and we can go ahead and allocate the face properties here and assign standard mesh specification. So returning to the top level assembly, I can go ahead and create a new finite element model, and I'm going to pick up on my wing mesh template. We can see here that it's picking up the mesh specification from that wing, but it's going to apply it now to the new surfaces. Straight away when we create the finite element model, it has enough information to start meshing. And if we have a look now, we can see immediately the mesh representations have been generated. You can see that internally, finer mesh has been used, allocated to the correct surfaces from those components. So in this way, we can take the knowledge and experience of meshing one assembly, and we can reapply it to the correct surfaces in a similar one.
Okay, so as you can see, this is kind of using a lot of out-of-the-box functionality, and as mentioned in the video demo that you just saw, this kind of work with assembly of FEMs, so you can have an assembly of parts and bring that in. This also can work in a batch process, so you can kind of do this offline, and it will run through a whole set of parts and associated templates, and there's a lot of ways you can extend this, and we're not really touching on kind of setting up the boundary conditions or the more specifically as well, the connections within the file. So again, there's ways to automate that. But some of the easy win benefits here, simple to set up, and you can share those templates in the team, so you can sort of standardize on what you're doing. You can run in batch mode. We will share some, along with the video of the presentation that we share after this with you guys, we'll also share some links to some interesting tools. One of them is a tool to help with the tagging. So in that process, you saw there was a lot of adding tags to the geometry, which then drove the meshing criteria. So again, we've got some tools which can help with that side of the process and streamline that. And so there's a lot of options there. So it's kind of an automated meshing example. And just to give you a sense, and this is the sort of thing we see with a lot of our clients, I've picked out one example here. Client here was shared sort of some of the gains they've had by doing this, but significant improvements in their model preparation time. And we've seen this with with many of our clients. And a lot of this is kind of simple. It just needs the work to set it up and organize it. But yeah, 60% reduction in model preparation time is significant in the process, and that leads you to be able to do more engineering work. So the last example we had for you guys, and to act as a bit of inspiration, is to look at this automated heat sink simulation. So here we're coupling together a 3D simulation with a cost calculation, and we're doing this in a tool called HEADS, which is sort of like a workflow engine. So what we have is a geometry of our heatsink, in this case in NX, but it could be in any CAD package. It doesn't have to be in NX, but it is parameterized. So you'll see in a minute we can kind of adjust the size and the fin layout and so on automatically. Then we pass that geometry, or should I say the HEADS workflow will pass that geometry into STAR, which will do a thermal analysis and pick out key temperatures. So again, you could see how this could be applied to lots of different engineering use cases. And then the final step is to take the data from the geometry, the sizing, the materials, and come up with a cost. And in this example, we're kind of extending it to those enablers we saw at the beginning, where optimization, machine learning, etc. So in this particular case, we could run an optimization to minimize cost and minimize the temperature or hit a particular temperature constraint we had for the design. So HEADS is going to basically kind of join these simulation tools together for us. And just to see how that's done, sort of another demo here to talk you through the kind of HEADS setup and the results. So first up, like I say, you need some geometry in this particular case, and it's a parameterized geometry, in this case in NX, and you can see you can adjust the design through parameters. So we're inside the HEADS interface, and we're building out our automation process. We've got a lot of out-of-the-box, what's called portals to connect to software. In this case, we're going to kind of use the out-of-the-box NX portal, and we're going to pick up our part file, and HEADS will then interrogate the part file and figure out all of the different expressions that are available for modification within the file. And we can then expose those to our workflow, and we can drive them as part of our workflow. So we've picked out the key dimensions here. You can then just ask the NX code to generate a step file in this case, which we can pass into our star analysis. So we already have the star analysis set up. It's going to expect a step file in this particular case. And we're going to set up HEADS to pass the output of NX into it. So this is what's happening on the screen right now. But we are also interested in getting some results out of star analysis. In this case, the temperature and the weight of the heat sink. So those then become parameters that are accessible within the workflow. And is also, HEEDS will take care of all the execution. So in this case, it will run the codes, extract scenes, and run everything in order. And the final step here is to add in our costing model. So in this case, it's a very simple Excel spreadsheet. A lot of engineering is still done with Excel, and we can integrate that into our HEEDS process. It's using named cells here, if you're familiar with those, to pick out values, but you can also go in and directly pick values off the Excel spreadsheet. So each cell you can read and write values to, which is quite intuitive and simple to set up. Then once you've built a process, you want to run it. So HEEDS has a bunch of options to handle the running. So it will orchestrate each of these codes and allow you to potentially set up, for example, star running on a Linux cluster or on a remote machine, or even on the cloud through some rescale type technology. So you can have something running locally, then going out to an HPC. HEEDS will manage the results and the staging of that. It will also initiate parallel runs. So you can do, if you've got the ability to run 4-star analysis simultaneously and they take a couple of hours to run, you can seriously reduce the runtime, total wall clock time of the overall run. So we've moved on now to the kind of HEEDS running the analysis. So you can see it's starting to run. I think this is about 300 or so runs that it's going to try and do in this particular setup. It's set up in this case to kind of optimize, but you could just do a parameter sweep or a design study with this. As it's running, you can see results coming back in. So we've got 2 feasible designs and 6 designs in progress at the moment. And you can visualize the data that's coming back from each of those runs, and the images that you can see extracted there. And again, we've got a final run. So this has been running for 6 or 7 hours and orchestrated all these runs. And then to kind of look at the results, there's a lot of capabilities to look at the results because you're generating a lot of data. Each one of the rows here in this design table represents a single run. And this is a simple view where you can filter for different characteristics. You can see the outputs, the temperatures that we got from the star analysis and the cost versus what we gave it as an input on the NX side here. And so you can use this to kind of do a parameter sweep, like I say, a simple run, or extend this into the optimization design study world. So as you can see, you can kind of use a tool workflow engine like HEEDS to quickly automate existing simulation processes, connect them up. There's a lot of out-of-the-box portals you saw briefly in the video, so we can connect to a lot of codes quickly, and that allows us to read and write data to and from those codes. If you've got like an in-house simulation code, something that's a bit more specialist, then HEEDS it's got sort of something called a generic a portal which can read and write input-output files, which is usually the way simulation codes and solvers work. And there's also like really extensive Python API where you can run stuff as well and create your own portals. But generally speaking, when we work with clients, we're able to integrate most stuff with the out-of-the-box portals. And then, as you saw in the video, once you've got it captured as a process, you can then get HEEDS to help you distribute that across your compute resources. And obviously, once you've captured the process in a HEEDS workflow, you can create templates which you can reuse and share knowledge. So it's kind of a way of capturing knowledge. And as you saw, you can then start to do design studies. Again, we'll share a little bit in the follow-up, but one of the steps this allows you to do is kind of go to things like HEEDS AI, which is a simulation predictor. So as the jobs are running, for example, in our heat sink, the AI technology would start predicting design points and adding those in to your runs. So effectively reducing the overall runtime and ideally in an optimization getting to whatever the best results are more quickly. So these are all options that you can build on once you've built up on the workflows. So a little bit, and I think that is our last example for today. I'm going to hand the ball back to Chris just to talk a little bit about Maya and kind of wrap up.
Thank you very much, Adam. So the first thing we're going to get asked is, how do you get started? It usually kicks off with an assessment. We want to know have a look at data availability, assess your current tool set and processes, what you want to keep, what would you want to improve on, what you want to change. This can be driven by past issues, little glitches that you keep seeing in your process. Talking to some of your more mature guys, the more experienced guys in your team that probably don't document everything, but have a process of their own that they undertake. Then we kind of go into a discussion phase where we identify some quick wins. Where's the low-hanging fruit? Let's work on one of these projects, show some ROI, and develop a target case. So then we iteratively work to the best-in-class solution. Once we've containerized that, we deploy, we roll it out on site, train your guys, and support you. And that's not the end of it. Once that's in work and being used, we can refine that process, and then we generally would move on to other projects if that's successful, which we would hope it would be. I'm now going to launch a quick poll. This is going to take a few seconds. Please quickly whiz through this, and we'll capture this. It helps us with our future webinars, and see where what we're doing right, what we're doing wrong. And also, if you quickly do that, don't forget the chat window. We've got a couple of questions come in, but we might have room for a few more. So pop your questions into the chat window. I can see the results coming in now, so I'll leave that just for a few more seconds, and then I'll close that down. So if you can quickly click on the answers, and we'll move on. And I can see, right, okay. And thank you for those of you who put questions in the chat window. Just to key you up, Stuart, the first one came in through while you were doing your first presentation. So the first question said, and it's heading to you. Right, I will close that down now. And then we'll go over to questions. So the first one, Stuart, for you is, how long until you see an ROI on this type of project?
Okay, so specifically on an NX Open project, I guess, if the question came in through from that period, but I guess this depends on the size of the project. So for example, we delivered a project last year for an F1 team, which sounds pretty glamorous, but it was really pretty basic. So a 2-week project where we created an NX Open app to help them transfer from an old style legacy drawing border with text and notes in there to a new style drawing border in their new version of NX. Like I say, it was a 2-week project, but we packaged that up, deployed it, and they had an immediate return on their investment. And so I think the approximate figures were about 30 minutes per sheet that they saved time on. So obviously the engineers were having to do that manually. And when you've got thousands of drawings with multiple sheets on each of the drawings, then obviously that scales up massively. And then I guess at the other end of the spectrum, there's the large scale projects where a company is looking to transform the way that they work fundamentally. And for these projects, you're probably looking at a longer development phase, but there's also a bigger return on the investment after that development phase. But all these projects are delivered in an agile way, so we try to deliver value as soon as possible during the process. So drip feed through bits of capability that's gonna add value. And I guess it's worth just adding as well, we tend to find that with the smaller projects, when we deliver them, they lead to bigger packages of work. Once they've been deployed and the users are seeing the benefits, they start thinking, oh, I could do a bit of NX Open here, and that's going to really benefit me. And we tend to get more projects off the back of ones that we deliver. Hopefully that answered the question in a roundabout way.
Thanks, Stuart. Yeah, so the next question is, yeah, that's going to be with you, Adam. You mentioned AI on your slide and that you have a dedicated team. What is their experience?
Yeah, Chris, so, okay, yeah, so I did mention AI, and I talked about it in the context of the HEEDs and simulation, building reduced order models, which you can then use for kind of predictions or for quicker design iterations. But yeah, in addition, we also have at Maya a dedicated AI team whose actual big focus is around manufacturing and taking data from manufacturing processes, using simulation of that manufacturing process to enhance it, looking at improving quality on the line, you know, by predicting early if there's issues. And it's really interesting what you can do with simulation models on that. Also, like looking at reducing energy use, those kind of things. So we've got a fully dedicated team to kind of AI ML projects. I work a lot in collaboration with them on the simulation side. So yeah, that's the Maya AI team. Chris.
Okay, thanks, Adam. I've got another question come in. How much of what you've shown would be possible using the FEMAP tool?
Yeah.
I guess that's Adam.
Yeah. So a lot of what we've shown is possible. FEMAP is, you know, similar. In terms of, I imagine that the question is coming from seeing some of the stuff on the batch meshing. So yeah, we could follow up with the person who asked that question, and we can take you through some stuff more specific to FEMAP. But yeah, we do actually do quite a lot with FEMAP, with the automation of FEMAP, a lot of experience. So yeah, we should be able to take you through some of the equivalent type functionality there.
Okay,
yeah, and just to add to that, Adam, it all integrates with HEEDs quite nicely as well. So.
Oh yeah, good point. So yeah. So you can drive similar things with HEEDs that you just saw in the demo. It could have been FEMAP, not STAR.
Okay.
Yeah, exactly.
Well, this will be the last question. Just looking at the time here. Do you have any examples with additive manufacturing simulation?
Yes, lots of examples actually, and so obviously there's different types of additive processes, but we've done quite a lot of workflows, kind of end to end really. So tools to support the automation of the design side of things for additive, topology optimization, designed specifically for different manufacturing techniques, and then we're able to simulate like the printing process as well, to you know, look for different aspects or track the different aspects of the manufacturing process to make sure that things don't warp, you know, get clashes in printing the product that you're making, and that it actually has the structural integrity that you're looking for at the end. So yes, and we've again done automation in this space. Again, if the person who asked the question is interested in finding more, and I see actually the questions around powder bed, so very much so, yeah, we can simulate the powder bed process, and yeah, take you through that, and yeah, doing it full end to end. So
yeah, and again, just to add to that, I've done a project with a company doing some cold spray, automating the creation of the cam paths to integrate with the robot, and to simulate the process as well to make sure that you're getting the output that you think you're getting when you run your machine, essentially, before actually running the machine. So yeah, quite a bit of experience in that space.
Okay, well, I'm going to start to wrap things up there. You will be receiving a recording of the presentations today, which includes this slide at the end. So you've got our contact details. So once you've reviewed the presentations, you know, more questions are likely to come through. Please do, you know, contact us and we'll answer them directly. I'd like to thank you for your time in joining us today and thank our presenters, Adam and Stuart. So without further ado, I wish you, have a great day and thank you very much for joining us.
Cheers,
Thanks,
everyone.
Chris.